Hello everyone, this is a video lecture for Calculus 1 section 4.1, Mins and Maxes. So what are they? First off, let's make a nice cubic function, and you can see right here we have a maximum, and right here we have a minimum. Now, they're often going to use the word relative mins and maxes, because if you see, this is the maximum in its neighborhood. That's a technical math term, and that's the minimum within its neighborhood. Like, if you keep going up, you'll see, like, right here, is that more of a maximum? What about this one? What about this one? What about this one? And the point is that there's always going to be something higher. This is just the top of a hill and the bottom of a valley. That's it. It's not the top of Mount Everest, and it's not the bottom of the Pacific Ocean. Those would be called absolute mins and maxes. So to kind of put all this together, they start with 41005, which is like a picture, and I'll just describe to you what's going on. So we got a solid, and then it goes up, and then there's a circle. I want my circle to look a little bit better. There you go. And then it dips down, and then it comes up. I'm trying to just copy this weird little graph thing, and then it sharp corners, and then it comes over here with a solid, and then there's a circle, and it does a circle. Okay. We need to label all the mins and maxes, basically. How the homework works is like find the x value and put it together. I'm just going to point at it. So this right here is not a maximum. The reason why is because it has a circle there. It's like an empty hole. And you would think, oh, well, this then is the maximum right beside it. Well, yeah, but what is that point? You can't really find the true maximum because the true maximum just doesn't exist. Well, this right here is a minimum. We can all agree on that. This is a maximum. We could definitely agree on that. This is a minimum. It doesn't have to be curvy. If it's sharp, it's fine too. Now, I would not be talking about this or this one being a min or a max. Those are not really what we're going for. If it kept going, then yeah, we could talk about it. But because it's sharp breaks and it's like a jump discontinuity, it doesn't have that max and min on both sides kind of thing. So I wouldn't even really talk about that. This guy looks really low, but again, he's not a minimum because you can't really find out what that exact point is. So we're just learning what they're considering maxes and mins, and it's just basic. It's the bottoms of valleys and the tops of hills, and that is it. If it doesn't qualify under just the basic principles, it don't qualify, and you move on. So keep it simple. So 41021, it says find the critical values. Don't know what that is. What is critical values? I'll tell you. Actually, it's kind of funny because I haven't told you, but that's okay. These are the mins and maxes. Okay, so I'm telling you ahead of time. Critical values is the mins and maxes. Kind of like an all-encompassing thing. And they give me this function, f of x is equal to x cubed plus 3x squared minus 45x. Now, I'm sure there's a lot of ways to doing this. If you graph this and then you're like, oh, I see, it's right there and right there at these x values. Yeah, I mean, I guess, but I'm not assuming that you have a graphing calculator for this. We're not going down that road right now. So we're supposed to use calculus in order to find the mins and maxes, and the way to do it is a formula. It's very simple. F prime of x is equal to 0. There it is. Solve for x. We're basically just going to be doing this the whole entire time, and that's okay. So find the derivative, set it equal to 0. So we got 3x squared plus 6x minus 45, again, equals 0. Solve for x. The best way to do this is if we factor it, and notice that I'm factoring out the 3. That makes it a lot easier. And so I can factor this down, what two numbers multiply to 15 but add up to a 2. and that would be a 5 and a 3, positive 5, negative 3. So then we have our answers at negative 5 and positive 3. So what do you put in the box? You put a negative 5, comma 3. And there you go. The order does not matter. It doesn't have to be negatives and then positives. Just type the numbers and you're good. Okay. 4, 1, 0, 3, 5. So it says the same thing. G of y is equal to y minus 3 all over y squared minus 3y plus 9. Same thing. G prime is equal to 0. Solve for y. I mean, there's nothing new here. Find the critical values by taking the derivative, set it equal to 0. Well, you can see that this is going to be a quotient rule. So low d high minus high d low all over the square of what's below. And so low d high minus high, back up, always watch to the end, back up, d high, what's the derivative at the top? It's 1. Okay, and then high, d low, what's the derivative here? 2y minus 3, all divided by y squared minus 3y plus 9, and then all squared, so divided by the square of what's below. And I'm supposed to say this whole thing is equal to 0. Look how big this thing is. So let me tell you as we go here. Let's just stop and pause for a second because this is crazy. We're gonna have to figure something out. What happens if I do this? What is this equal to? 0. What about this guy? 0. What about this guy? 0. What about this guy? Still 0. And so the only way to get 0 for an answer is when the top is equal to 0. This is back from college algebra days. Does this have anything to do with the bottom? Not really. I mean, it would be good to know that the bottom is not also equal to 0 and thus canceling something, but that is very unlikely for this class. So I'm just going to tell you, I'm going to take the top equal to 0, and it'll be okay. And so we got y squared minus 3y plus the 9. Over here, we're going to have to FOIL this thing out. So we got 2y squared minus 9y plus 9, right? Because we got, basically we got our 3 and 6 will make a 9. Okay. Distribute the negative. Again, we got all this stuff here is equal to 0, and I'm going to do that very often, or I might just forget about it entirely, because we don't need the bottom to solve this thing. It just gets in the way. Again, whatever's in the bottom. Okay, combine like terms, so we got a negative y squared. These guys right here make a positive 6y. And then the 9s actually cancel. That's kind of nice. I'm going to forget about the bottom entirely because we don't need it. Factor out a y, and so we get a negative y plus 6. And so we get two answers, y equals 0, and here we get y equals 6. And so then in your box, you would put 0, 6. And you're done. Okay. So finding critical values. Super easy. Here's another one. So this says find the absolute min and maximum. This is going to be a slightly different procedure because they're saying absolute means we have to look at some endpoints and stuff. We're still doing those critical points, relative mins and maxes, derivative equals 0, all that. That doesn't go away ever. But we will have to do a little bit more math here at the very, very end. Okay. So they say we have this function, and we're looking between these two x values, and go. So this is a cubic, and I'm just going to make some kind of cubic up like this. But they're saying, hey, we're only looking from right here to right here. Find the min and max. Well, let me zoom in and tell you what that would look like. Here we go. I'm just looking at this right here. Wouldn't this right here be my absolute maximum? Wouldn't this here be my absolute minimum? but those are also the relative mins and maxes. Okay, well, what about this guy right here? What if it did this? What if this is how it ended up with the bounds? This is -3 and this is 4, you know? Well, then I have a relative maximum, but this right here would be my absolute maximum. This would still be my absolute minimum. What if it kept going down like this? And it curved, and then it did this thing. What if we got that section? Well, now you can see that this would be your minimum, and this would be your maximum. And then the relatives don't even matter. They're just a little swoopy whoop in the middle. They don't really bother me, I guess you can say. There's all these different options, and I don't know which option we're going to have. The main point is that we're going to use the endpoints and those critical points that we were finding from, f prime equals 0, that kind of stuff. So we're going to do this, and we're going to take the derivative and set it equal to 0. And so what we get is a 12x squared minus 12x minus 72 equals 0. I think you can factor a 12 out, leaving behind an x squared minus x minus 6. And you can factor that thing. So that would be a minus 3 positive something. Yeah, -3 positive 2. Okay. So then we got x is equal to 3. X is equal to -2. And then we got these guys here. So let me list them all out in like a number line order. So I have -3. So that's one of them. I got -2. That's something. I don't know if it's a min or a max, but again, looking at the pictures, it's going to be a relative max. Way over here, we have a +3, and then we have a 4. And so these are all, I mean, I know that critical points, endpoints, I just generally call these critical points at all because we're going to be checking all of them anyways, okay? So, what do we do now? So these are all possible answers. Well, which ones are they? What I'm going to do is just test each one. And so you go f of each value. You basically plug it into the original, not into the derivative. You plug it into the original. Flipping my page. And you see what you get out of it. So let me just go ahead and give you some values here. I got a +55. Here I got a +89. This is all just calculator, of course. -161 and a -127. So this right here is definitely my absolute max. And this right here is definitely my absolute minimum. So it just so happened that it was the curves, I guess you can say, that were the minimums and maximums and stuff like that. Here, hold on. I didn't do that right. I'm still not doing that right. I want to make sure I'm going to do it right here, okay? Yeah, that'll work right there. Okay, so we have these 4 points. And I'm saying, well, which ones of these are the highest and the lowest y values? Well, this is definitely my maximum, and this is definitely my minimum. And there you go. We proved it. No other points in here will make sense, so we only use the endpoints and the critical values, and it's got to be from that list because nothing else will actually work in calculus land. So there you go. All right, 41059. And so I've got f of t is equal to t minus the cube root of t, and they're saying go from -1 to 5. Just like the last time, I'm going to find my derivative and set it equal to 0. That'd be a 1. This is a 1/3 t to the -2/3, and I'm going to set this equal to 0. When you move that over to the other side, you get 1/3 t to the 2/3, -2/3. Give me a little bit of room right there. Move this over so you get a 3. Now, I don't really like that style, of course. What this is trying to say is, there we go, this guy, denominator. You can move things around. This might all be a little bit too fruitless. And so we have the 1/3, and now this is going to be to the 3/2. To move this over, you just do the reciprocal of the fraction power, blah, blah, blah. Okay. So, yay! Whatever. I don't really know. Yay! What am I supposed to do with that? Like, seriously, what is that? Well, I do know it's a decimal. I can tell you that much. It's probably somewhere between 0 and 1. So, is that good enough? Maybe. I don't know. The other values that we have are the -1 and the 5. So we're going to test all three of these in the original. And so f of -1, f of 1/3 to the 3/2 power, and then we have f of 5. And I'm telling you, this is calculator. This is calculator. I just went and did all this calculator stuff. Okay, so I plugged it into the original. That means this guy. Okay, and use a calculator. Desmo Scientific is totally legit. You can put in like x equals -1, enter, and then you can type your function and with the x's in it, and then you just replace your x. It is so convenient and easy. No need to go and retype this stuff every time. And so what I got were these values here. And of course, these are all approximate because I'm just got around at some point. And so this one here ended up being my minimum, and this one here was my maximum. Now I don't know exactly what this kind of graph would look like. I'm not going to go there, but you found these two values. Now they don't want the decimals; they want the actual value, exact answer kind of things. So to get the exact answers, you do basically have to plug it in, but as you've probably known by now, I am a big fan of not simplifying, and that is okay. There you go. As sloppy as it is, there's your minimum. And then for the other one, it's a lot more easy. Anyways, there's your maximum. There's your min. There's your max values. I don't think they want to know what x value it's at, but if they do want to know, you can obviously give it. 41065. So I got f of x is equal to ln of x squared plus 5x plus 8, and we're going for the interval -3 to 1. All right, so let's find some derivatives. Derivative ln is 1 over stuff. Then that stuff is complicated, so take the derivative of the inside, multiply it. And again, we're setting this thing equal to 0. Note that, yet again, I only want the top equal to 0. And what does the top look like in this case? It looks like that guy. So you can quickly get an answer of -5/2 without doing much math at all. And that's good. We like that. Of course, we still also have these other 2 points we have to consider. And so in my original, not f of x, I'm going to do f of -3. I'm going to just show you, just so that I know I haven't done this ever, because I really don't care to do this. This is all calculator. But what I'm actually doing each time is plugging this into the original, just like you see it. Okay. And for me to write this out every time is just silly. Silly is the best word I can come up with. And the same for you. I mean, I think writing it down in the notes once is probably okay. But, I mean, really, you don't have to do this. There are things called calculators, scientific calculators, that can just do this for you. And that's good. So 0.693... 0.5596 and 2.639. And so again, this will be my minimum, this will be my maximum, and so these are your answers that you could plug in the box. I mean, you could simplify. Here, let me go ahead and simplify these two to you. Okay, here, I actually did it on my notes. So that's ln of 7/4 and ln of 14. I mean, all I did was just put these guys into the calculator separately first, and there you go. So it depends on your level of wanting to type, obviously. Next question. I think this might be the last question. Yeah, okay. So 41030. And so I've got f of t is equal to 7t minus, plus 7 cotangent of t over 2. And same thing as always. They give me some kind of interval here, pi over 4. Oops. And then we got 7 pi over 4. Okay. So derivative equals 0. So 7. Cotangent. What's the derivative of cotangent? It's actually a negative cosecant squared. But because we had a complicated inside, we have to take the derivative of that inside and multiply it out here. And the whole thing equals 0. Okay, so 7 minus 7/2 cosecant squared of stuff is equal to 0. I would definitely move this over, and I guess I can move the 7/2 over from there. You ever want to just do some of these steps without having to write it all down all the time? And actually, the 7's cancel, ends up with a 2, which is a totally legit answer for a cosecant, and cosecant squared at that. So it's actually telling me a lot. If I square root both sides, you get the square root of 2, but you got to have that plus and minus. Now, often we just say plus and minus something over here. I'm going to do the plus and minus right here because it really doesn't matter. I just want to make sure that something's going to be plus and minus. And so I'm saying that the cosecant is equal to plus or minus square root 2. This kind of can get confusing. And so what I would rather say is I have square root 2 over 2. I don't want to make that big of a leap for you. I'll get there in a second. Okay, so 1 over square root 2 is equal to sine. Okay. And this right here is equivalent to saying square root 2 over 2. Rationalized denominator, something like that. So this is what we're really after. We got sine values are equal to plus or minus square root 2 over 2, which definitely would be at 45 degrees and stuff like that. Now remember that we're still dealing with t over 2. And so I'm saying that my t over 2, the angle on the inside, should then be one of these angles. And so I would like to say 45 and 135 and all that kind of stuff. Well, we're going to do the radians, so pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and it'll keep going, but that's good enough. I'm going to multiply by this 2 to the other side so I can get t by itself, which is what we need. So this is pi over 2. This is 3 pi over 2. This is 5 pi over 2. This is 7 pi over 2, and so on and so forth. Well, our interval was from pi over 4 to 7 pi over 4. So let's just kind of understand number line-wise what we're talking. We got 0 here. This is pi over 4, and we got 7 pi over 4. I don't think number lines are really the best way to do this, but whatever. And this is 2 pi, full revolution. So these are my answers. These guys are way outside of 1 revolution. 5 pi over 4 is like way over here, and so on and so forth. So we don't even need these. Pi over 2 is like somewhere right here, and 3 pi over 2 is somewhere around right here. So what I'm saying is that these guys here meet the criteria of being within our interval. Okay, so this is our interval, and these two are actually inside of it as well. Therefore, my list is going to be this pi over 4, that's an endpoint. Pi over 2, that's a critical value. 3 pi over 2, another critical value. And then the 7 pi over 4, which is another endpoint. These are all possible answers. And so what I'm looking for is which ones of those are correct. And so, just like every other time, f of pi over 4, f of pi over 2, f of 3 pi over 2, and f of 7 pi over 4. Calculator, calculator, calculator. Make sure that you're in radian mode. Those little things like that are very important. Flipped the page, and I got everything I ever wanted plugged into this thing. And so I got 22.397, 17.995. I got 25.987, and I got 21.585. This is my min. This is my max. And so the actual values that they're going to want is when you plug it in. So 7 times pi over 2 plus 7 cotangent of pi over 2 divided by 2. How would I put that? I'm going to do this. Pi over 2 divided by 2. There you go. All I'm doing is I'm going back to my original f, which is, well, right here. I'm just plugging it into that. And I am just leaving it as it is. So there you go. You could just do that. I mean, if you want to simplify, that's cool. Cotangents of pi over 4s and all that's not too hard to find. But I'm just saying, don't overdo it. If you can type it and you like typing, do that. If you like writing, well, whatever. So, good. And that's actually all I have for that section. Cool. So, thank you very much, and have a great day.